Hello everybody, this is Todd Frazee again, and this is the video tutorial for the S60-129 CAD for the part called crank. This is a crankshaft, not really a shaft, but a crank device. It's also brass, and this is for the the Sterling 60 series. Now, we could make this several different ways. We could revolve it and do some cuts, but I'm going to give you some more practice doing extrusions on this one. We got several features here, so we're going to start with the base that has an angular shape to it. If we look at our drawing, it's laid out here, and the dimensions we need is this 34 degrees, the 980 thousandths diameter, and the width of 730 thousandths for our first dimensions. And we also need to determine the difference between the 291 thousandths and the 120 thousandths, which is the thickness of the part. But we'll come back to that. Alright, so let's start. We're going to start by drawing this 980 thousandths diameter features. Let's go to SolidWorks. We're going to create a new part number. Go ahead and save off the part number with the correct name when you first start. And we're going to make our planes visible. Okay, we're going to sketch in the front plane. And we're going to start by making a circle based on origin. We're going to take that circle and we're going to right click on it and use this icon here to turn it into construction geometry. So it's now construction geometry. We can dimension it, but it actually isn't part of the part. We can drive other geometry from it. Okay, once we've done that, we can put our dimension on here, which is a diameter of 0.98, just under an inch. Okay, so we can use this to drive the arcs that are at the top and bottom of the part. So we're going to go to arcs, and we're going to change from center point arc to 3-point arc, which only requires a start, end point, and third point to define the arc. And we'll repeat that on the top to create our arc. Now we have a 730 thousandths dimension. It is going from end to end here. So we will go ahead and align these endpoints so they are always horizontal. First, you select on the first point, hold the control key down, select the second point, and we're going to put a horizontal relationship so that no matter where this goes, they're horizontally aligned. Now we can throw that dimension on there of 730 thousandths. Okay, so that is the correct width now. And what that'll allow us to do is draw a line from the endpoints of that arc, and the endpoints will be placed in the correct place. Now we're going to put a dimension, angular dimension, on those two lines. And our dimension was 34 degrees. Okay, you notice one canted and the other didn't. So we should put another angle dimension from there to center, which is going to be 34 divided by 2, or 17 degrees. So we now have the angle correct and equalized along center line. And now what we can do is use drag the endpoints to these lines. Take the endpoint of the lines and we're going to make them coincident. Drag this one back to merge. Take this endpoint, make it coincident, and then drag back the other endpoint. And we now have a shaded space in the center, and this should be fully defined. There's nothing left unconstrained. We still have the negative symbol over here, so we're going to try rebuilding and then go back into our edit our sketch, and the negative symbol's gone away. So it was fully constrained, it just needed to rebuild. We can exit sketch. We go to a 3D view so we can see this take on thickness. And we're going to go to features, Extruded Boss. And I didn't have my sketch highlighted like I normally do, so it's now highlighted. And then we need to tell it how thick it's going to be. So let's go back to our drawing. And if we subtract 120 thousandths from 291 thousandths, we get 0.171. So 171 thousandths. So we're going to type that in, 0.171. Press enter. And we now have our base feature, which is this triangular looking shape. All right, next we're going to create the larger boss feature that sticks up 0.12. So that is the 470 thousandths diameter. All right, so we're going to do a sketch, and we're going to select the top surface of the part, and then we'll make a circle, and that circle is going to be centered on where origin projects onto the top of that part. We drag our arc out. We have a dimension to put on it. It's 470 thousandths. Gives us a fully constrained sketch. And we're going to go to features. We're going to exit sketch. And we're going to do another extruded boss at 120 thousandths in height, or 0.12. We'll accept that, and we've got our larger boss. Now let's go back and look at our drawing. We've got a smaller, really thin boss here. It's more like a washer shape. You can see it's only 8 thousandths proud from the surface. Okay, so we're going to go in and make that, and it's 240 thousandths in diameter. We're going to repeat the procedure we just did. We're going to select the top of the part as our sketch. We're going to make a circle centered on origin. We'll dimension the outside diameter. It was 240 thousandths. And then we accept that dimension, exit the sketch, make sure our sketch is highlighted. We're going to go to features, and we're going to make another extruded boss, and its height is going to be 0.008 or 8 thousandths. And we'll accept that feature. Alright, we're moving along pretty well. Now all we have to do is make the press fit hole that's here and a threaded hole that's a feature in the crank here. Let's start with the pinhole that's up here. We're going to just do a regular sketch. So we're going to pick the top surface, and then we're going to draw a circle approximately there. Use the escape key. We want to highlight the center of that circle, and when we select the right hand plane, we can make those coincident. So we at least have it aligned on center line in the vertical axes. Now we need to give it a dimension for its diameter and for its distance to center. So let's go back to our drawing. And it's a 061 to 059 through hole, which is 60 thousandths would be the the nominal size. So let's go back to SolidWorks and put our dimension on it. It's 0.06. And then our dimension from center to origin there, if we look at our drawing, is 354 thousandths, or 0.354. So we're going to put in 0.354. And we now have that sketch fully constrained. We're going to accept the dimension. We're going to exit the sketch. We're going to highlight the sketch. We're going to go to Features. We're going to do an Extruded Cut, and we're going to change the type to Through All. So it goes all the way through the part. And we've now finished the pinhole. The only component feature we have left is the threaded hole in the center. So if we look at our drawing, it's a 632 UNC, and it has a depth of 210 thousandths. Now I just realized something. At 210 thousandths, with how deep the drill has to go, it's going to poke through the other side of the part. So we're going to up rev that drawing so that it's a through hole. So let's not worry about the depth, and we're going to up rev that drawing to be 632 UNC through. So hopefully you'll see a drawing that's up rev for that. So we're going to use a hole wizard. We go to hole wizard. We tell SolidWorks we want a threaded hole type, and we want that to be a tapped hole, not a bottoming tapped hole. We're going to change the size of the tapped hole to 632. It's going to go through all. When we'll leave the we're going to leave the with thread call out. We're going to get rid of the near side chamfer, and we're going to include the thread class, which is a 2B. Once we have all those parameters set, we're going to go to position, and we're going to select on the plane where the hole's going, and we can now drag the hole around, and we're going to snap it to origin, and that'll place it. Now we don't want to pick anywhere else because we just want the one hole. Hit accept, and we get our threaded hole that goes all the way through the part. Okay, let's I'm gonna hide the planes, and if you want to change the material type to reflect brass, the part's made out of brass. Okay, that's the end of the tutorial for the S60-129 crank part. Thank you for listening, and I hope you got something out of it, and I'll see you on the next tutorial.